I wanted to follow up on a couple of things that Bill said, and he's very kind. He referred to XYZ mathematics. He may remember that Arnie Packer at Johns Hopkins called that XY mathematics, and so you've added the Z. So I don't know if you get a co-authorship there or not. I would also add one name to Bob's list of two people who were the fathers of quantitative literacy. I worked pretty hard on this, and Lynn Steen is such an intellectual resource, and he's the most magnificent writer I've ever encountered, editing with him it's absolutely wonderful. But Bob Orell was the person who really he really is the person who ramrodded this effort that Lynn and I both started working in around the turn of the century. That sounds okay, doesn't it? But it used to sound a lot older than it is now. But Bob Orell is a historian now, and he's a Rhodes Scholar, and he was at the College Board before he retired. He's still working on his education in Bucks County, Pennsylvania, and interchanging emails with Bob Orell is an absolute pleasure. It comes out as almost poetry. I mean, it's just, the historians can write, especially historians like Bob Orell. I would want to say one other thing about the high school curriculum. I was at the Future of a High School Mathematics Conference in Washington, D.C. Within the last year. I don't remember exactly when. I was invited to participate in that, and Dan Chafin from the University of Maryland, the head of the Center for Math and Science Education, I think there, was going to get up. He was getting up and kicking off the conference, sort of like Bill did here. And there was a room full of people. And Dan came over to me and said, I hope you won't mind, I'm going to quote you. I said, ooh. So he said, when I had been out at the University of Maryland to sort of a workshop on this issue a little while earlier, and he said that I had described the high school curriculum in mathematics as all algebra all the time. And I think I did say that, but I want to. That's not a bad place to start here, because there is. I've gone on site visits for NSF, and so I remember going to Orange County, California, and they had decided to teach algebra in the 8th grade, as all of California has. I figure it's going to be in the 6th grade pretty soon, but it's you know, it's content creep. So but it's going the other way. So in Orange County, they had decided some of these students had a little bit of trouble with Algebra 1. So their solution was, and it's a solution that people do, they decided to teach it in 2 years. Okay? So I was sitting in on a class. I was listening to this teacher teach this out, and I just couldn't imagine those students sitting there. If it takes them 2 years to get through Algebra 1 and 2 years to get through Algebra 2, they're going to be seniors, and they're going to listen to this stuff for 4 years. It isn't working. But that's one of the reasons that I got involved in this, because for a long time I've looked at introductory college mathematics. And I'd looked at introductory college mathematics from a policy point of view. When I was at the National Academy doing the NRC, not the National Academy, and there's a difference, and you have to understand what that is. But I was at the NRC doing the MS 2000, the assessment of collegiate mathematical sciences in the year 2000, and this was about 1986, 87, when we were doing the calculus reform movement and stuff like that. I was looking at the big picture of college mathematics enrollments and what was happening to students and where they went. And it didn't look good to me. It looks like a very inefficient and ineffective system. And I don't think there's any way that we can look at those data and say that it isn't inefficient and ineffective. So when I stopped being dean in 2000, and I said, okay, you gotta look a little deeper at these issues, and you gotta somehow, if you don't believe it's working, then you gotta find something that might work better. Well, so that, I said, if I do that, I have to go into the classroom and I have to immerse myself in working on this problem. And so that's what I've been doing. That's what I've been doing. And what I want to do this morning is to try to give you a feeling for the academic issues involved here. There are, John Dewey said a lot of things, and he has some of them most of them I agree with, and I understand I don't know the real context for this, but it's sort of what I'm trying to get across, and it's sort of what I've learned in dealing with students. What I think it is, and I worried about this some years ago when we started doing online education. I was dean then, and when we were talking about online education, and I expressed reservations about online education. I said, I think we have to educate people the way they live. And I don't think people live in isolation. I think there's a social structure here that that is important to education. Now I've been wrong about that, but I think it's important that we recognize that education, there's a life that's going on around our students, and there's a world there that they need to understand, and it is important that we get them to understand that world and understand how education relates to their lives as it is. Now, Dewey said something else, and this one just fascinates me. Maths could be learnt via learning proportions in cooking or figuring out how long it would take to get from one place to another by a mule. Now, what he's saying here, I think, is that we can actually learn mathematics by doing mathematics. That we can actually, that we can, and I want to make a point that traditional mathematics is not taught that way. The pedagogy in traditional mathematics, and it may be the pedagogy in your own disciplines, and forgive me, I know more about mathematics than I do about your discipline, but I'm glad you're here to help because we need you. But we have a pedagogy that says we present finished work of the masters, and we say, look at this, look at this, look at this. This is beautiful stuff. Isn't it nice? We don't think about it that way. We don't create it that way. We teach it very differently than we create it. And we expect students to learn how to do it when we tell them how it looks when it's finished. That's like expecting students to learn how to paint beautiful art by showing them work of the masters. Now, knowing the work of the masters, you learn some characteristics of the work of the masters, but you certainly don't learn how to produce them. So it's a difference. There's difference here. So what we've got to do, I think we have to learn mathematics by using mathematics. And you learn mathematics and you learn about mathematics by looking at how mathematics, and I'm not talking about tough mathematics, as you'll figure out here in a few minutes. I'm talking about middle school mathematics. I'm talking about mathematics that you all know how to do. And statistics. Every time I say mathematics, add statistics to it. Mathematical is what I'm talking about. Now, I want to say a little bit about literacy because this has been brought up. Bill said we're all quantitatively literate to some extent, and we are. But there's different kinds of literacy. Now, literacy itself has two meanings. It can be minimal, and a person is barely literate, or it can be maximal, the literati, the intellectual, the intelligentsia. And those are two things that we continually struggle with when we talk about literacy. Now, there's another two kinds of literacy that Lawrence Crimmins used in the American Education, the Metropolitan Experience in 1988. And this was quoted by Bob Orell in Mathematics and Democracy. And it's inert literacy, and that's just the basic literacy. But then there is this liberating literacy, and it's the one we have to look at. The command of both the enabling skills needed to search out information and the power of mind necessary to critique it, reflect upon it, and apply it in making decisions. Now, it is that from which the National Numeracy Network takes its vision, that the National Numeracy Network envisions a society in which all citizens possess the power and habit of mind to search out quantitative information, critique it, reflect on it, and apply it in their public, personal, and professional lives. Now, that's different. It's not basic literacy. It's not being able to just add and multiply, being able to do functional mathematics. It's much more complicated than that. Now, there have been lots of definitions of quantitative literacy or numeracy. By the way, numeracy is the word that is present, that's used in most of the world outside the US. You'll see numeracy in Europe, you'll see numeracy in Canada even, because it originated, and I'll get to that in just a minute. But I won't read you all of these. You can read them yourself, or you can ignore them. But the bottom one, though, I want to point out, it's something that Bob Orell sent me in an email. Bob's a historian, remember. And it says, Bob said, it's a cultural field where language and quantitative constructs merge and are no longer one or the other. That, to me, captures the essence of what I'm talking about. And it also says to me that quantitative literacy is the better term, rather than numeracy, because numeracy is this concocted word, is too tied to number. But this is number and words, and they're merged. They're no longer one or the other. It's all of our business. Now, there are relatives of quantitative literacy or quantitative reasoning. There's mathematical literacy, which is different in my view, and I won't go into why it's different. There's numeracy, there's symbol literacy. Bill mentioned some of these. Document literacy. Document literacy came in the National Adult Literacy Survey. Document literacy, prose literacy, and quantitative literacy is the way they separated the literacies that they were measuring. Financial literacy, statistical literacy, quantitative reasoning, critical reasoning, analytical reasoning, scientific literacy, symbol literacy. These are all related. Now, ethnomathematics is on that list, and ethnomathematics is contextual mathematics. It's buried in cultures, ethnicity, and it's very important when you're teaching Navajo kids to know the Navajo culture, because it's not taught the same way as it is taught to us Anglos. That's different. Now, there's always a question of mathematics versus QL. What is the difference? Well, some years ago, I was asked to talk. Not some years ago, a couple of years ago. That's some. I was asked to talk about.
Quantitatively speaking.
Peggy will keep me straight here. Okay. I was asked to talk at the NECWL, give this kind of talk at NECWL, New England Quantitative Literacy, New England something, Quantitative Literacy, Consortium, New England Consortium for Quantitative Literacy. It's some bunch of private colleges in New England, and it's absolutely beautiful. We were up there in October. Nice. Anyway, mathematics, you can see the differences here. Mathematics has its power in abstraction and generality. I mean, that's what makes mathematics so powerful. It's abstract, it's general, and it's because we can, and people who can understand abstract and general stuff are able to use mathematics in very powerful ways. But people who don't think that way, think more in concrete terms, don't quite do it that well. Now, on the other hand, all QL problems are contextual in my business. When we talk about QL, and I will talk about it in a minute, we don't talk about anything that's not contextual. And we have another criterion, which I will mention here. And by the way, I'll be happy, I have these. What we're trying to do is produce not a textbook, but, and by the way, this isn't promotion because you can't buy this. And even if you did buy it, I don't get any money out of it. So we're trying to produce a volume of case studies on quantitative reasoning as the core for teaching our course. Now, what is in here are media articles, newspapers and magazines, and study questions about those. Now, there are some exercises that get students primed to deal with the case studies, and those are fake. I mean, we make those up. They're all contextual as best we can. But what do we include in here? We don't include any topic that is not, we can't find in the media, is not in here. That's our criterion. That's our criterion for putting anything in here. If it isn't out there, I don't care how much mathematics, how much it is in mathematics in school and college, we don't do it. It's we are dealing with the mathematics of the students' world, their contemporary world. And and I think that's justifiable. I don't think we have to worry about, I mean, my students tell me, one student wrote about this course when, you know, they asked him to write things, and the student wrote something that I just love. He said, this course takes off of the table once and forever the question of where will I ever use this? It's irrelevant. It's irrelevant. And it also takes off of the table the criticism that you're just making it hard on us. You're just doing this. And I said, no, I don't do this. This is your world. This is your world, and it's out there, and you got to understand it. So I think we have a lever to get students more involved. Now, we believe there's a canonical QL problem situation, and we believe not too different from the scientific method and not too different from the data analysis questions that you have to deal with. We believe that there's a canonical problem situation that students have to, they look at something, they have to have the confidence to take up the challenge. Now that's what's missing. In fact, in the book that out of the NRC that Brad was one of the editors on, Adding It Up, they have a very nice model of mathematical proficiency in there. One of the strands of that mathematical proficiency is something called productive disposition. They actually listed it last, fifth. But I think it's the most important one for these students. It says that if you believe that it's important for you to do this and that you are capable of doing it, and it can mean something to you. Productive disposition. That's missing in so many of our students. They don't believe they can do mathematics, and they don't believe they can do statistics. They don't believe they can do social studies. They don't believe they can write essays. They don't believe they can do these things. They can't write poetry. They have to work at that. I mean, that's something different. But we've got to get past that. We've got to be able to measure this productive disposition and deal with it. They've got to look at this thing and glean out relevant information. There's so much stuff around it. There's stuff. And then they've got to estimate, they've got to compute, as my students say, and I say, on the fly. And my students even use that phrase now. Oh, I did that on the fly. Yeah, okay. Tell me about the fly. Okay, but, all right, but that's important. I mean, it's one of the articles that's in your packet here, and I'll get to it, and we'll get to that. I'm not going to talk forever. But the thing is that one of the articles by Paul Krugman, and I like the Paul Krugman article because it gives me a chance to tell students, we know what Paul Krugman's political stance is. And if you don't read the New York Times. Paul Krugman is a liberal economist, but he's a Nobel Prize winner now. My students were impressed. We had an article by this person who was in the news as a Nobel Prize winner. So we knew who that man was. We had read his article. Krugman in there once, it's an article written right after, a column written right after 10. Let me get back to that. I tell my students, we're not interested in evaluating or being informed by Krugman's political position. What we're looking is at the quantitative arguments that he makes to support that position. And we're analyzing those. We constantly wander into areas that are sensitive. Political issues, social issues, things like that. You've got to be willing to go there. You've got to be willing to go there. And sometimes I'm very uncomfortable going there. But I go there with my students. If you ever talk about parking in class, you will get a lively discussion, and you will get, we had a graphic, there was a pictograph of the comparisons of the number of parking spaces allocated to students and to faculty and to some other people. And there were cars per parking space, or permits per parking space. And there was a stack of cars over the student thing, and there was half a car over the paid parking in the new indoor do-which-it that cost us $9 million. The students were really fussed about that. They said, look at that. They understood that graph. They understood it perfectly. And they wanted to talk about it. So you have to go with them. So be wary that if you do this, and you know that, you're dealing with students all the time, you got to go with them. So okay, now compute on the fly, you've got to model some mathematics or statistics. You've got to do the mathematics or statistics, and then you got to reflect on the results. Now the only one of those that we really do is next to the last one. Do the mathematics or statistics. That's what we really do. We give them the models. We give them the models, and we do that one. Now, they aren't used to reflecting. They don't even know what you mean by that when you start. But you finally learn how that works. I want to go back just a minute to tell you why I think quantitative reasoning, quantitative literacy is a little different than it is been conceived over the past 50 years. The first appearance of the word numeracy appeared in a 1959 publication in Britain, in the United Kingdom, that defined numeracy as simple arithmetic skills normally acquired in childhood. Now this kind of minimalist position lasted until the Cockcroft report, another UK report in 1982, where Cockcroft said it's the ability to use mathematics in everyday life. So it became mathematical. It became, the mathematics applied to everyday life. But in recent years, it's begun to be much more of what Bill was saying earlier. It's understanding numbers. It's understanding that statistics are socially constructed. It's understanding the interaction of society and numbers. It's interacting what numbers mean to people. It's how people personalize numbers. Bill was doing that with his units on $1 trillion. One of the exercises we do with students is, how much is $1 trillion? Can you change that to some units that are personally meaningful to you? Now what Bill did was say it's about $13,000 per family of 4. Okay? Well, the tax burden in this country is something like $10,000 per person, the total tax burden. What is $12 trillion? What is our national debt? It's about 1 year's income or 1 year's gross domestic product. That isn't too bad if you were paying it down. And I say that to students. It's not too bad to owe a year's pay. And that's the thing. But if you don't pay on the credit card bill, it eats your lunch. So that's. But what I try to do is get students to translate these numbers into, and we use big numbers. We don't use small numbers. 1 times 10 to the minus 9th is not in my students' vocabulary. It's the big numbers I'm trying to get them to understand, and big, of course, to me is relative. But what I'm saying is that the idea of quantitative reasoning, quantitative literacy, and numeracy now is much more integrative across disciplines and across cultures. It's much broader than the mathematics used in everyday life. Now, the approaches to QL are in college, and there isn't much of this in high school. Although the state of Arkansas has a course described, frameworks for a QL course. It is really a framework. It's just got the studs there. Not much flesh on those bones. But what colleges are doing is they pre-test students, and some of them have to take a QL course, or some of them don't. Now, pre-testing is another issue. What kind of test do you give people to decide if you need to take course? And then they have a selection of menus for existing courses. That's the one that's been around a long time. You can take this philosophy course, you can take that civil engineering course, you can take this math course, you can take that sociology course. That's kind of crazy, but it's the way we're doing it. There's QL modules in courses across the curriculum. In other words, a QL module in a history course, a QL module in a sociology course, a QL module in a music course, and a QL module in various courses, different kinds. Then there's QL modules. There's QL modules across the curriculum with a theme, like at McAllister College, where they do public policy. So everything is public policy. Everything is about public policy. So you could do QL across the curriculum on higher data if you want to. But I want to run through. These characteristics of QL friendly courses. So mathematics is encountered in as many contexts, as many as you possibly can. Political, economic, entertainment, health, historical, scientific, whatever. It's important that they do that. The pedagogy has changed from the pedagogy we use in mathematics, from presenting finished material to looking at specific cases and developing the mathematics you need or the statistics you need to do that problem. You then remember it. The material is encountered in the real world, unpredictably. You don't go home with 10 problems that are template problems, and you know exactly what formula or method you're going to use to solve those 10 problems and learn how to solve those 10 problems. You see something and you've got to figure out how to use it. Now, I'm not saying that it's wrong to do 10 problems, but I say that's not what you do of the same kind. That's not what you do here. And much of the material should be fresh. And fresh in students' mind is this morning. It's not last week, it's not last year. They are really tuned to the now and then. I mean, and so you have to work really hard to keep things fresh. Considerably less mathematics is covered. You don't cover mathematics content here. That's not the idea. The idea is to use the mathematics as it occurs to you. The mathematics is often elementary. In fact, people ask me, is your course a college level course? Well, in my view, I was asked that in a room full of statisticians at the joint statistical meetings. And I said, as far as I'm concerned, any course that I teach in college is a college level course, as long as the students don't know what's in it. So that doesn't, I mean, if they don't know how to do it and it's important, then it's a college level course, for gosh sakes. Come on. I mean, we get hung up on this stuff about, now, is the level of the mathematics that they're using legitimate college level mathematics? A bit of it is. A bit of it is. I mean, a bit of it, but most of it's not. Most of it is using numbers. Using numbers, quantities. I say numbers are adjectives. Units are nouns. And my students get tired of me saying this. I say, 6? 6 is the answer? 6 what? Okay? Everything has a unit on it. We're not in our class because it's a contextual problem. We're trying to figure out something. So units are important. Technology, at least graphing calculators, is used to explore, compute, and visualize. And I want to do just a little bit of that. Thanks to Greg, I have a calculator here, and it's got tied to this thing up here, and we can do this. I want to show you how we use the calculator, and how I think it's important in what's a little bit unusual ways. Now, this is important to you. QL topics must be encountered across the curriculum in a coordinated fashion. A conspiracy among the disciplines. This can't be done randomly. It can't be coincidence. It has to be a conspiracy. Conspiracy means we're connected. We're working together to produce some outcome here. It can't be random, and it can't be coincidental that we do these things. It has to be a conspiracy. That's why we have a State Department of Education to direct those conspiracies. You call them initiatives, right? Now, an interactive classroom is absolutely essential. I mean, the hardest thing I have to do is get the students to talk. I have and these students are students who say, I don't know how to do mathematics. This is a course that has a math prefix. I'm scared to death. I can't do this. I'm not going to talk about it, whatever you do. And I changed some of them's mind. One of the things we first do in the class, first thing that I ask them in class, are there any articles today? What does that mean by that? What I say is students get points, bonus points, for bringing in articles that they've analyzed that have quantitative information. That's the way we keep the class fresh. That's the way we keep the class fresh. You brought in a student brought in an article on this last Tuesday that was just absolutely fantastic. He said, this is really simple. We got through with it, and I said, you said that was simple? What it was a graphic, an article about how much money is awarded in punitive awards in U.S. courts, and I think they meant federal and state, in awards that are over $1 billion. Now, if you look at the graph of that, the graph went just a little bit, and it got big, and then it got way up here in 2000, and then it dropped down to almost 0. And we were trying to figure out what it meant. And we had to do some backup of percentages and things like that. Before we got through, I said, you thought that was simple? And the student did a marvelous job of bringing that in. And we learned what punitive damages are. We had pre-law students in the class. They said, oh, punitive means you get penalized for, it's not damages, it's not medical cost, you get penalized. They decided you did something wrong, and they penalized you by fining you this $1 billion. So they learned something. You've got to be willing to go there. I have a family full of lawyers, so I don't mind. So now, here's the challenges. QL is a habit of mind rather than a content-rich academic discipline. It's a habit of mind. You can't say, what's the content of QL? It's hard to say. It's whatever comes. Whatever comes. It's a habit of mind. Habits require practice. Practice, practice, practice. Okay, how do you get students to practice? Why do students forget algebra? They don't practice it. I ask my students, they can't do algebra. They've all had college algebra or got that box checked. But it's not very useful to them because they don't remember when and how to use it. But they don't practice it. When's the last time you saw a quadratic equation in the newspaper? Or anywhere else for that matter? Besides in a math book. You see exponential equations, you see linear equations, but quadratics, cubics, polynomials, they're not out there. Rational functions, no. You don't see them. So therefore, they don't practice. We've got to provide them a venue for practice. That's what we try to do here. What we try to do here is we try to give them, I'll just leave these with you, and you can take a look at them. I need to take them back. I promised somebody from Miami University that I would bring to them, but I don't have very many. What I think we try to do with these students is the newspaper, the magazines are a venue, provide a venue for continued practice. If we can get them to analyze, in a semester I can't do much. 14 weeks, 2 days, 2 class meetings a week. What can I do? What I can do is teach these students how to analyze these things and then send them off with presumably enough, enough questions about what is it I'm reading here that they will read it and that they will actually continue to do that. I'm telling on myself here, but I don't mind. I buy wine. I was talking to somebody earlier about taxes on wine, to Richard. But I was down at the liquor store next to our house, and one of my students, it was Christmas time and it was after the semester, one of my students was working in there. And he said, I walked up to put my stuff on the counter to pay for it, and he said, "Oh, you're my math teacher." I said, yeah, how are you? And he said, I'm great. And I said, how did you like the math class? He said, I loved it. He said, I said, well, has it meant anything to you? He said something that just really made, I bought another bottle of wine. He said, I use it every day. Now, what else am I going to do? What else can I do? I mean, he says, I look at ads, I look at things, I look at labels, I look at everything, and I think about them quantitatively. So there. I mean, he will continue to learn, I hope. I hope he will continue to learn. Now, but there are other challenges. Now, many of the students believe that this is just another math class, and they expect methods, they expect template problems. Now, they also don't believe it's relevant to their lives. I have to disabuse them of both of those things. First of all, we don't give template problems, and that irritates them. They get a little irritated with me. They say, what? I don't know what you mean by that question. Just show me the formula, and I can work it. Okay? All right? I said, well, I'm not going to do that. In fact, I don't even want you to remember the formula. This is not a course where you memorize formulas. In fact, they're taking a quiz about now. Actually, it should be over by now. But my colleague, Shannon Dingman, who's the other person on there, we're revising that, by the way, and we're writing a instructor's guide for it. It should be out by the fall, if I can get back to do it. But on a quiz, they're allowed to have a piece of paper, an 8.5 by 11 piece of paper, to write anything they want on it. They have to have a piece of paper that has anything they want to write on it, and they sometimes have trouble filling up the 2 pages, but it does 2 things. It says, I don't want you to memorize this stuff because you'll forget it. what I want you to do is I want you to learn how to reason and transfer that reasoning to different contexts. So there we, that's what we're doing, and they get over being irritated at me, most of them. One young woman came into my office and sat down, and she said, "I'm not doing well in this course, and I'm not happy about it." And I said, "Well, let me see." Yeah, she was doing pretty well. She had a B or something. She said, "I don't make B's. I'm an honor student, and I make A's." I said, "Okay, you can make an A." And she said, "And I did quite all right in traditional mathematics. I was good at it, and I'm not so good at this." I said, "Well, okay. Well, let's work on something that you're not so good at." Because and of course she made an A because we got her turned around and she was fine. But they do react negatively to that. Now, abstracting generalities from contextual examples is difficult pedagogy. That's why we don't do it. That's why we don't do it. It's difficult. And it's problematic in the sense that you may not be able to do that. Now, multiple contexts challenge QL faculty and student understanding and knowledge. I mean, faculty development is a major issue here. Before you undertake anything in Ohio to do this, you've got to have a plan to get your faculty ready to do it. I have trouble with my own faculty. We're teaching 3 sections of the course now. One of them is with a graduate assistant. We had a full professor teach it last semester, and he did quite well at it. But I was watching him. He was good. He was good. But he said it's too hard to teach. So we went back to teaching honors calculus. Huh? And I mean, he's a wonderful colleague, he's a friend, and a good teacher in what he does. But he didn't, it was hard. It's hard to do this. You have to work, you have to read a lot of stuff, and you have to correct a lot of stuff. You have to use rubrics that you're not used to using. The course material must be fresh and engaging, and that's hard. The excursions into political and social issues are sometimes delicate, mysterious, yeah. Mathematical and statistical concepts occur repeatedly and unpredictably. I mean, you may encounter some kind of measure of central tendency, you may encounter something like a confidence interval, you may encounter these things, and you have to go off and deal with it with the students. We encountered a confidence interval the other day in a course about heart patient care in hospitals across the U.S., and the article was that the Forbes Hospital in Pittsburgh was highly rated. And what does that mean? Well, there's a confidence interval around the average of 18% of the people dying within 30 days in certain kinds of cases. There's a confidence interval. It's not that you only have 17.3 people dying after 30 days. You may have 16 people and you still may be called average. So we encounter those kinds of things, and they're unpredictable. QL requires practice beyond school. You can't do this without students. You've got to build the students something to work on. Now, assessment is a particular challenge. It's really difficult. Assessment of QL requires authentic tasks. Today on my quiz, there was an article that the students had never seen. It's authentic. It's authentic. And I asked them questions about it. I said, every quiz we take has those kinds of questions on it. So you won't have seen this, but you will have seen similar things, and you will have to answer the kinds of questions about that you have. So it requires, and this requires what Wiggins calls authentic tasks require construction of knowledge, discipline, inquiry, and value beyond school. And I really agree with him about that. Now, we don't know what the learning goals for QL are. We're working on them. But when you sit down and say, what is it I want the students to be able to do? One simple way to do that, which is what I read a science educator from George Mason wrote in an article recently I read, exactly I agree with him. I want them to be able to read the newspaper. Huh? I want them to be able to read the newspaper. That's not a bad learning goal. I want them to be able to understand it. And it's fairly simple. I want to be able to read the New York Times. If you want to do it more difficult, if you're really a high-level institution, do The Economist. If you want to move it down, do USA Today or the Columbus Post-Dispatch or whatever. Okay, okay. But, is that what it is? Post-Dispatch? Dispatch, okay. Now, in order to do this, we've got to develop some kind of developmental steps for QL, and we don't really know what they are. And we don't know what standardized tests can show us about QL learning. And what should we value and what should we score? What is it we value? Do we value precision in language? Do we value accuracy in computation? Do we value other things? What is it we value? Can we assess whether or not students are inclined to practice? How are the skills that they have and the skills that we're looking for related? I don't know the answer to some of these questions. I would love to know. Okay, now, this is a model I think you should keep in mind if you're going to develop. This was written, this book was about early childhood, early elementary grades, K-8, but it's applicable anywhere, I think. I don't think this model, I like this model. It breaks up mathematical proficiency into 5 strands, intertwined, no doubt. And the conceptual understanding concepts, we've even adopted that one. We've embraced that one. We think people need to understand concepts. The second one, procedural fluency, we've always embraced that one. In fact, that's where we teach and test mostly, because it's easier. The strategic competence, we don't get very much with that. Are students able to, can they develop strategies to solve problems? The adaptive reasoning, we get at that, but we don't get very good evidence on it. Can you adapt reasoning from one context to another context? That one's important for QL. Can you adapt the reasoning from a tax rates to somewhere else? And then the one that I said was most important, productive disposition. Do you believe it's important? And do you believe you can do it? And that's, that to me is a big hurdle. This is where most of the students who are in the quantitatively illiterate category, and I don't use that phrase with my students. I don't call them illiterate because I don't think they are. But that's where they're weakest. That's where we need to do more work. They gotta believe it's important, and they gotta believe they can do it. And so that's what I work very hard on. So thanks, I'll be around all afternoon.